Hey everyone, and welcome. So, have you ever looked at your own shadow on a sunny day and thought about what's really going on? It turns out you're actually witnessing the very same physics that creates one of the most incredible events in the entire cosmos. Today, we're going to connect those dots, all the way from a simple shadow on the sidewalk to the mind-blowing scale of a total solar eclipse. So let's jump in and see where it takes us.
I mean, we've all seen pictures of it, right? Maybe you've even been lucky enough to see one for yourself. That incredible moment when the day suddenly turns into twilight, everything goes strangely quiet, and the sun just disappears from the sky. The big question is how? How in the world can our tiny moon completely block out the massive, blazing sun?
Well, the answer, believe it or not, has everything to do with something we see every single day. The secret isn't some super complicated astronomical equation. Nope, it's the simple, elegant physics of a shadow. So to understand this cosmic sleight of hand, we first have to get a handle on what a shadow really is.
That's right, we are starting with the absolute basics. And it might sound a little elementary, but I promise you, the rules that make a shadow for a tree are the exact same rules that govern planets. Once you really get this, you unlock the secret to something that has amazed people for thousands of years.
It seems pretty straightforward, but let's break it down. To make any shadow at all, you just need three things. First, you need a light source, like the sun or even just a lamp in your room. Second, you need an opaque object. That's just something light can't pass through, like your hand, a building, or, how about the moon? And third, you need a surface for that shadow to fall on, like the ground, or, say, the entire planet Earth.
Okay, now this is where it gets really cool. If you look closely at pretty much any shadow, you'll notice it isn't just one solid block of darkness. It's actually made of two different parts. And understanding these two parts, that's the key that unlocks the whole mystery of an eclipse.
So first up, you've got the umbra. Just think of the umbra as the shadow's super dark core. It's the sharpest part, usually right in the middle, where the object is completely 100% blocking the light source. We're talking total darkness.
And then surrounding that dark core, you have the penumbra. This is the fuzzier, kind of grayish area you see around the edges. In the penumbra, the light source is only partially blocked. So some light gets through, but not all of it. This is why the edges of shadows often look soft and blurry.
And check this out. This diagram shows it perfectly. See the light source on the left and the object in the middle? That dark cone of total blackness it creates, that's the umbra. And that wider, fainter region around it is the penumbra. The size of the light and the distance of the object totally change how these two zones look.
Here is a great real-world example to think about. Why don't you see the shadow of a bird or a plane when it's flying way up high? It's because it's so far from the ground that its dark little umbra, that core basically, disappears before it can reach you. All that's left is a huge, super faint penumbra that's so spread out our eyes can't even pick it up. Keep that idea in your back pocket. It's super important.
Okay, so we've got our rules down. Umbra, penumbra, light source, opaque object. You are now officially an expert on backyard shadows. So let's take everything we just learned and scale it way up to the biggest stage there is, space.
See, just like a tree, the Earth and the Moon are just big, opaque objects. They don't make their own light. So when the sun shines on them, they cast these absolutely enormous, cone-shaped shadows that stretch for hundreds of thousands of miles out into the void.
So, you've got Earth casting its massive shadow, and you've got the Moon casting its own shadow. And they're both constantly moving around each other in this kind of cosmic dance. So, what happens when one of them just happens to pass right through the other one's shadow? Well, that's it. That's an eclipse. And that brings us to the main event. Now that we're pros on how shadows work, we can easily explain the two major types of eclipses, solar and lunar. It all just comes down to a simple question. Who's casting the shadow and who's standing in it?
First, let's talk about a lunar eclipse. This is what happens when the sun, the Earth, and the Moon line up, but with the Earth smack dab in the middle. Our whole planet casts its giant shadow out into space, and the full moon sails right through it. So when you watch a lunar eclipse, you're literally watching our own planet's shadow move across the face of the moon. How cool is that?
This breaks it down really simply. For a solar eclipse, the moon's in the middle and its little shadow falls on us. For a lunar eclipse, Earth is in the middle and our big shadow falls on the moon. It's really all about the lineup.
And here's the other side of the coin. A solar eclipse. This is the reverse. The moon passes between the sun and the earth, and for just a few incredible minutes, a tiny little spot on Earth's surface passes through the moon's shadow. From our point of view, we are literally standing in the moon's shadow as it races across the planet.
So, here's the most important part. To see a total solar eclipse, you have to be standing in that tiny, dark core of the shadow, the umbra. If you're standing in the much bigger penumbra region, you'll only see a partial eclipse, where it looks like a bite was taken out of the sun. It's the difference between seeing the main show and just being in the cheap seats.
Okay, so we've been talking a lot about what happens when light gets blocked. But let's hit pause for a sec and ask, what even is the light that's traveling from the sun? It's actually made up of zillions of tiny individual packets of energy. Any idea what they're called?
If you said photons, you got it. It's these tiny little energy packets, these photons that journey all the way from the sun, get blocked by the moon, and create the amazing shadows that we call eclipses.
All right, let's bring this all back home. We started with a super simple idea, a shadow. And we ended up explaining one of the most spectacular shows in all of nature. It's just a beautiful reminder that the universe, as complex as it seems, often runs on some very simple, very elegant rules. And this, right here, is the big takeaway. The physics that makes your hand cast a shadow on a wall is the exact same physics that makes the moon cast a shadow across the Earth. The rules of light, opaque objects, the umbra and the penumbra, they apply everywhere, from the smallest scale to the most massive.
And that leaves us with one last thing to think about. You know, right now, we use the tiny shadows of distant planets crossing in front of their stars to discover whole new solar systems. It's amazing. So it really makes you wonder, what other incredible secrets are out there, just hiding in the simple dance of light and shadow across the cosmos?